To solve this equation, it's much easier if we first express this complex number in polar form. As you can see, I've marked in the complex number here on an Argand diagram, so the task is to calculate the value of the modulus r and the argument theta. Now, I've done a previous video on this. You can also use the graphic calculator to do this. So we enter the complex number, -4 plus 4 times square root 3, and I is down here on the 0 key. Now I need to access the options menu, then complex, go to the next menu, and it's one of these conversions. I'm in rectangular form. I want to convert to polar form. And I get immediately that this is 8, and this symbol is used for cis. 8 cis 2 pi over 3. Now, we should recognise, yes, 2 pi over 3 makes sense. That's an angle here in the second quadrant. But really, we could have 2 pi over 3 plus another complete rotation, which would be adding 2 pi. We could have 2 complete rotations, adding another 4 pi. So really, this is plus 2k pi, where k takes the value 0, 1, 2, 3, etc. Now we're ready for the cube root. So we have the complex number, 2 pi over 3 plus 2k pi, and instead of z cubed, I'll put all of this to the power of 1/3. Now, using de Moivre's theorem, this would be 8 to the power of 1/3, or the cube root of 8. And when it comes to the angle, we multiply by the exponent. So it's 2 pi over 3 times 1/3. And this is times 1/3, so we'd have 2k pi over 3. Now, the cube root of 8 is 2. This is 2 pi over 9 plus 2k pi over 3. Remember, k can take the value 0, 1, 2, etc. So our job is now to substitute successive values of k, simplify, until we get unique solutions. Once they start to repeat, we don't need to go any further. Because this original equation was z cubed, we expect 3 unique solutions. Let k equal 0. Z would be 2 cis 2 pi over 9. If k is 0, this part's nothing. If we let k equal 1, z would be 2 cis. Now we have 2 pi over 9. And if k is 1, we have plus 2 pi over 3. Now, if you're not confident with the fractions, you can go 2 pi over 9 plus 2 pi over 3, using the fraction key on the calculator, and we see this simplifies to 8 pi over 9. Uh, 2 pi over 9, 8 pi over 9, definitely different. Now k equals 2, so there's no repetition here of the solutions yet. 2 cis So we have 2 pi over 9 from the original solution. And if k equals 2 2's, this is 4 pi over 3. Once again, we can just go back and repeat this, modify this last one. So we had 2 pi over 9 plus 4 pi over 3 becomes 14 pi over 9. Now you can probably see a pattern here. 2 pi over 9, 8 pi over 9 differs by 6 pi over 9. 8 pi over 9 increase again by 6 pi over 9. If we go again, if we increase that by 6, we'd have 20 pi over 9. And if you think about it, 20 pi over 9 would be the same as this with a full 2 pi rotation added. So we have our 3 unique solutions. This one, there's our second one, and there's our third one there. Of course, we could mark them on an Eigen diagram, and you'd find that these 3 solutions were spaced equally around the complex plane.